Hello and welcome to MobileWarsaw. It is my pleasure to open, I believe, our 20th second meetup, which is so great because we're getting closer to a year and we will have a surprise in 2 months. So please do mark the date, 20th of April. We'll have something special for everyone. We will? Yeah, probably so. So mark the date. And as I said, welcome everyone, and I would also like to very warmly welcome everyone who has not been here before. Who hasn't been here before? Raise your hands. Which is amazing, because as usual, we have a lot of newcomers, which is great. As a reminder, we have official sponsors, which is Allegro, who is paying for the beer and the recording. I mean, sponsors are paying for the recording, yes. So Allegro is paying for beer, so thank you, Allegro. Woo. Thank you, Mobica, for beer as well. And we have a new sponsor, and it is my pleasure to say thank you to El Passion, because of El Passion, we have a camera recording. So thank you very much, El Passion. Woo. And if you do not know where the videos go, they end up on our sort of abandoned YouTube channel, which will be resurrected, I believe, within a few weeks. So you will be able to watch whatever happens here pretty soon over there. And what? Yes. Back to you, Antek.
So, yeah. So, if you, we are generally open for speakers. So, if you have a talk you want to something you want to talk about, or you have someone who you would like to hear, then just contact us. We are very good at organizing speakers. Also, we are looking for flash talks. If you have a very small topic, we are welcome to talk to us, and we will arrange it. Actually, today is a very special day. We will have only one main talk, and then after that we will have 3 flash talks. So once in a while we will do something like that. I said about that one. Sorry. Also, if you have any suggestions, please write us at hello@mobilewarsaw.pl.
Hello everyone. Hello. I'm Bartek, and I recall some of you from other iOS or mobile-related events. Maybe you also recall me. No? Hello. It's okay now? Cool. I'm from Krakow. I'm first time speaking here in Warsaw. Quite happy to be. And I know this is like a mobile event, not only the iOS one. I'm mainly an iOS developer. Are here many people that are like mainly Android developers? Okay, there are a few. I hope you won't be bored to death by the end. And now, oh, I speak louder right now. My talk is about instruments and how I use it daily. And if you think it will be about GarageBand, well, I'm sorry. It will be this kind of instruments. And I wonder how many of you use the instruments like more than once a month? Oh, I thought so. I was afraid so. Basically, I'm using instruments quite often because I'm doing lower level stuff for the bass app, and I'm quite fond of them, of the instruments. Basically, what we can do with instruments, obviously, 2 main things: bug hunting, bug fixing, and some sort of performance engineering. Yes, obviously. And these are only 2 points, but basically they are strong points, as a lot of developers' work is around those tasks. Now I will just move straight to the point and try to show you how I work with some of the instruments, try to demo some stuff, and see whether you can grasp something from it. Let's start with allocations, yes. Obviously, the key point of this instrument is keeping track of the object's lifetime and showing us how many things, how many objects are alive in the memory. And we also get like full retain count history, so we can see what happens with the objects over the time and in which places they are kept and in which places they are like released. And another good point of it is generation analysis. It's like keeping the track of how the heap and objects on the heap change over some boundaries that we specify. I will demonstrate it shortly. And also this instrument is a foundation for the zombies feature. I won't talk about zombies today. There is like a load of resources over the internet that is about zombies and how to utilize them. And I really hope that if you are an iOS dev, you know how to use the zombies instrument, because it really saves time and helps finding issues related to the memory. Now, I will move to, hello. Okay, I will move to Xcode. There is a small project that I have, which I will profile in the instruments for you. I hope the resolution won't be an issue here. I really hope. As I said, I choose allocations. I maybe do it like that. Do you see it? I think it's okay, sort of. I hope. Okay, I lost my cursor. Now, I will play it on the, sorry. Obviously wrong target because I was testing something else. Once again. Cool old simulator. Now, let's just focus on the allocations itself for now and how we can use them and how I'm using them. Abandoned memory. What does that mean? If you can see, how many of you use that instrument? Okay, approximately half of people here. How many of you didn't use it but would like to? Okay, only one person, 2 persons, 3 persons. Okay, cool. Basically, what you can see is here, the amount of memory that is currently being used by the application. It amounts to 90 megabytes somehow, and it changes in time. Now, if we, for example, layout, okay. If we move back and forth, we see that this amount changes. And what we can see here is something that should disturb us, actually. That we move forward, backward, and the memory usage increases. That's never a good sign, actually. But how we can quickly discover what's the cause of that? With the generations. And if we go to allocations tool, because if we switch between these trace instruments, the options change. Here, we can mark generation. So we make sure we are on the main screen. We mark generations, which sets a baseline. And now, when you enter the screen and move back out of it, you expect memory to be in the very same state. So we again mark generation and can do it once again. What we see here is that each generation has a growth of 1.5 megabytes. Oh, even less if auto release pools like do their stuff, but still it's above 1 megabyte. Yes, that's not good. That means that we have abandoned memory. Memory that's not really a leak. Like it wouldn't show in the leaks instruments because there is strong reference to it, but is definitely keeping and staying in the memory. Now, what can we do with it? If we expand this, we can see that there is 1 megabyte of some kind of non-objects memory allocated. The question is, where? That's a good question. If we focus on it, we can see the lifetime of the objects here. And for example, the stack trace. So, let's have it here. I actually lost something here. Okay. We can see stack traces of stuff that work here, and okay, we have our 1 megabyte. That is a trouble, and we see exactly the stack trace we generated it. So we from here can traverse to the particular line of code and see that we are doing setup, and in the setup we are allocating the data. And we are doing this setup all the time from the shared instance. It's obviously a mistake. I put here to show you a problem, that every time shared instance is being accessed, it somehow allocates memory in the improper, incorrect way. Fix for it, it's simple, and obviously move the setup to initialization instead of doing it in a wrong way, like I did. And this leads to like this will solve the problem. Yeah, obviously. Now I won't fix it right now because I don't think that it's really important to show it, because it obviously will work. Yes, or do you want me to fix it? No. Okay. Quick answer. So that's one that's one thing how we can use the allocations instruments. The other one, I will start from scratch, is looking at the memory peaks. So when we open the screen and have something like work on some stuff, we can see peaks of the memory. Well, this peak is actually that does not look bad. Yes, it's small peak, really small. It's hardly visible for you probably right now. But considering that we have 20 megabytes of memory taken up front, then this peak is maybe a trouble in the future. Like if we have multiple peaks like that, we may like reach 200, 300 megabytes of them total memory used, and application will be killed. Just imagine this spike being bigger, and how we can like see what's happening inside. Obviously, we select, we time filter through it with the alt, and we see which kind of memories, like what kind of memory were being processed here in the call trees instrument. We can like hide missing symbols, hide system libraries, and see that our memory peak view controller has finished task, which basically is called before, which is called here, yes. And we see that in the finished task. Okay, so we are processing data, then finishing task. And in process data, we are having a lot of strings being like done, created, allocated, deallocated, and stuff. We can really quickly like solve this by going to the memory peak view controller, going here, and like specifying like auto release pool with, and move this code, everything to here. Yes. We will do this. We will kill the simulator. We'll go to we'll go to instruments, run it again, choose allocations, track this stuff, enter the screen, and we have almost flat processing here. That's good. We have no peaks. And well, maybe this peak didn't look scary to you. It's like, okay, some memory is being there, and it's okay for it to be like this small, but it's just an idea I want to plant on you, to look at it, to check some peaks of the memory and try to solve them, but by using auto-release pools properly. It's quite the basic stuff, actually, what I'm showing you right now. So, coming back to presentation here, I believe I'm on the different screen. Yeah. Allocations, yeah. Allocations are awesome in my opinion. They help you a lot, but we have to mind the performance overhead that they have. Like if you have really big synchronization going on, really big processing, and a lot of stuff is there, then it will like clog your computer and will slow down stuff really quickly. Also, it happened to me that sometimes allocations crashed with too many events, and or were lagging, and the stuff were not really up to date with everything it was showing. So, well, it's also good. It's always good if we can like limit the amount of background processing or background work while we are using allocations to track some significant problems with the code we are suspecting is doing something wrong. Next, leaks. Leaks are good, like allocations on steroids. It shows you leaked memory and can analyze the retain cycles. And that's also something really like basic, but many people miss the fact that when you choose the leaks and when you record stuff, we have like cycles. So yeah, we have leak here. Obviously, it's a leak. It's leaked memory that has leaked and cannot be recovered. So we're just occupying the heap space for us. And what's interesting here, if you expand this option, is cycles and routes, which basically shows everything what is about this leak. We can see that Allah has cat and cat has Allah. So this is our cycle. The problem we are supposed to solve resides here in the viewDidLoad of cycles view controller, where Allah and cat are being instantiated and both are assigned to each other, creating a cycle. It's pretty basic stuff as well, but many people don't know about this. And I think it's like it's a really good piece of knowledge to share with other people, even though it's basic, really basic. That's basically it about leaks, because tracking leaked memory and analysis of retain cycles and is quite simple, yes. And we can also like track the CF release, CF retain issues that often pop up with using the keychain or other like low-level APIs. It's all about that. It's also awesome, I believe, but it has the same amount of issues that Allocations tool, I believe, because it runs along with it. But besides, I had quite a few troubles with running it on iOS 8 devices. I actually couldn't get it to work properly on my iPhone 5 with iOS 8. That's why I had to like show it on the simulator in the end. but it's a good tool. It's useful tool, definitely. Next one is my favorite, actually. Time profiler. It's where the things are getting hot, and I like spending my time looking at the time profiler and what's going on inside. Obviously, it samples CPU usage over the runtime of the application, and it's low overhead instrument that is supposed to be low overhead since it's like measuring performance. Also, it's not really well known or widely used, it can be used to track waiting threads and deadlocks. And I will show that in a moment as well. Coming back to Xcode, let's see the CPU, the time profiler itself. Thank you for nothing. We have time profiler, which we run, and out of the stuff we can track here is CPU usage. Yes, okay, so obviously let's see the CPU usage. Let's say that someone was complaining that the scroll on this table is sluggy and it's not really working well. So let's see. Oh, it's like, where does this CPU come from? Yes, this usage is, if we observe this, that shouldn't look like that. Like accessing an object to display it shouldn't pick the CPU like that. It's like having a big peak on this MacBook once on this device. It's like making it hang. Okay, so what we can do about it is obviously with Alt pointing and selecting, looking at what exactly is going on here in the call tree, and using some nice options like hide missing symbols, hide system libraries, narrow it down to like 2 working threads. And as we can see, this one thread has 1 millisecond of the running time, while this thread has almost 1100 milliseconds. Over here, like 5 seconds, it's quite a lot. It's quarter of the time being used on the main thread. That shouldn't look like that. So we are looking inside it. We can simply invert call tree, which will put this on the top, and see that in the cell for row at index path, there is this truly random number generator. What the hell is truly random number? Okay, so someone assumed that truly random number is random number that was computed 4,000 times. Not a good idea. So we can imagine that solving this problem to like making it work as a proper random number generator will fix the stuff for us, yes? That was easy, really easy to narrow down. It's the basic usage. But right now, let's move to some more interesting stuff. Let's see, what does this mean, record waiting threads? This one. Anyone here used record waiting threads? No? It's getting interesting. Okay. So record waiting threads. Let's try to, I killed the instruments, sorry. Let's open this again. I select record waiting threads. This tab is generally responsible for what the given instruments will do. So how it's being set up. We start the recording and try to do some blocking this time. So we have really simple stuff, like we have array, we have table that lags considerably. Yeah, this is lag. Yeah, let's try again. This is lag. Something happens, yes, is laggy. But what's different from the last time is that we don't see increased CPU usage here, yes? It's unknown, like the main thread, in total time of the main thread is like in milliseconds over the time of the 20 or 30 seconds, so there shouldn't be an issue. Now when I stopped this run, I can change what I'm observing. I can like go for the cores to see what was the CPU usage. Okay, so CPU usage was not really big as well. So where may the problem lie? The problem may be observed here. What is different with the record waiting with this record waiting threads option is that besides this bright clock thingies, there are like bleak ones next to it. So each 10 milliseconds, the instruments sample what is each of the threads doing and is storing the stack trace of it for us to look at. And now we can see, traversing back and forth here, that for example, here, we have nothing, and suddenly we hit in the, let's see, 16, nearly 17 seconds, we have something here. And we are stuck. And here we are stuck all the time. Okay, I already moved half a second past, and the main thread is still at mutex wait command. What does it mean? It means that the main thread is trying to access shared resource that is being currently locked in by different thread. So we are facing multi-threading issue, not really a performance issue here. And this stack trace, again, shows us where the problem is. That this self-row at index path tries to access some shared resource here, which apparently is blocked somewhere. The question is where. So let's see in this time frame what other thread are actually doing. This does nothing. Oh, this was interesting. This does really some stuff. Let's see what. Okay. In the harass shared resource method, this thread on the global queue actually locks down the resource for the 2 seconds. So we see the problem here. It would be difficult to actually track with the CPU usage because there is no CPU usage. There is like a query over the resources. Okay, it's mine. No, it's yours. No, it's mine. We cannot really access anything, but the problem remains. The user sees locking interface. So the problem here is easy to solve by re-implementing this method and using, for example, some better way to implement multi-threading. That's really something neat about record waiting threads. And as you can imagine, catching a deadlock here is really simple. If you have an issue with the deadlock and you invoke these record waiting threads while catching the issue, you can see each frame before and what exactly caused the deadlock. What were the stack traces for each of the threads there. It's really powerful tool, really powerful. And let's move to the last one from the time profiler I'm going to show you today. Actually, something related to performance and multi-threading as well. But first, here are 4 cores. Each of the core has hyper-threading, so ideally we have like 8 threads working at the same time concurrently. So let's narrow it for the sake of this test. We can go to preferences of the instruments, go to CPUs, disable multi-threading, and limit it to 2 cores. It will simulate the device. We can only 2 cores on the iPhone, so let's work only with 2 cores here. And now when we run this, it will run only on the 2 cores. Multi-threading. Let's click it. Oh, we had some multi-threading. Oh, yeah, we have some multi-threading here. So let's see what exactly is this. Some stuff is happening here. Let's see what exactly. here we are having main thread is processing data. Cool. It's not a good idea to do it on main thread, but for the sake of presentation, forgive me. We are processing data here, enumerating data. Okay, cool. But are we really processing data using all of capabilities that we have? We have two cores, yes? We could be probably processing on the two cores, using both processors' power, yes? So, if we go to threads, we can see that, okay, something happens here on the, we have different four threads, and this main was working here on something. Okay, that gives us nothing. Cool. But if we go here, we can see that it was working on the two cores. Two cores, cool. Maybe we are really using the capabilities that our hardware gives us. Let's narrow it down to core 0 and core 2. So basically that's what it looks like. And let's zoom in. No, that does not look like a concurrent operation. It's generally main thread, which is switched between CPU cores. It's no big deal that threads can be switched between cores. There are cores are like used by the system itself, so it's natural for it to like be split between the cores. Yes, but it generally is not concurrent. It's not what we really expect from the code execution to be. So we have to go to the code right now and try to track the problem itself. And tracking this problem should be pretty simple in this case, which I wrote actually, because I know what's going on here. If you look at the code, we are processing data in the viewDidLoad after 2 seconds of the interval. Okay, in processing data, we are enumerating the data, doing some stuff. Let's say that this stuff can be processed in concurrent manner. Yes, okay. So I wrote some different method, like process data concurrently, when for the enumerate objects with options, I specify ns enumeration concurrent. Let's change this invocation. Make sure that everything is killed. And try execute it again for the time on the time profiler. Mind that these settings remain till you restart the computer. And we go. Off we go to multi-threading. Okay, that looks shorter. Notice how this is inaccessible right now. I have to stop the execution for this to reveal itself. We again narrow to 2 cores. We know that this is here, so let's just simply zoom in. Yeah, that does look concurrent, actually. Yes, this is what we are looking and aiming for while processing a lot of data, to utilize the hardware we have, not only like have a nice processing that takes time, but I try to optimize it with the capabilities you have. Okay, coming back to presentation. Again, time profiler, I believe it's truly awesome, but data mining could be improved. Like I missed some features like determining what was the peak of the usage, like when we have a bottlenecks that like could be tracked automatically. Stuff like that can be improved. I actually had quite a nice talk about instruments on the iOS 7 Tech Talks in Berlin with the Apple developers, and time profiler is generally something they put a lot of effort to, and they still will probably in the future as well. Core data. How many of you are using core data? Quite a few, yeah, quite a lot actually compared to many people that are here. out of those people who hate core data. Okay, minority, good. Well, core data has its quirks, obviously, but what about possibilities that instruments give us? We have powerful statistics for database access. We can measure fetch, save times, and track cache misses. And I think the cache misses stuff is the most important here actually, apart from the obviously optimizing the fetches and saves and the schema structure, obviously. But cache misses is something that is not so obvious, but can lead to really bad performance. Now, coming back to our beautiful Xcode again, let's see another tool. Like I said, core data. There is like core data fetches probe, cache misses probe, saves probe. Okay, let's run it and see what it gathers. Here, core data, cache misses. Okay, we have something like that. What does that tell us? Do you know how to interpret this? Or not? Not really, yeah. I see it's like off topic, but when I meet people like working with core data, a lot of them like don't use this tool, and they, for example, use the output that the LLDB gives us if we specify the debugging options. Some use the SQLite itself to like execute query plans on their or on their queries to make them optimized. But not many of the developers reach out to the instruments in order to develop to debug or investigate some stuff. So what we have here is like fetches in the first row, which we can see how many fetches we execute and what was the result and how long it took to finish such fetch. We had like two fetches here that took just above like, I think it's in nanoseconds. So we're pretty, or milliseconds? I don't think it took a second here. No, it didn't. It was like a really small piece of time. Nonetheless, this black thing, oh, it's ugly. Each of these represent catch miss. It means that we have objects in memory and we try to reach its property. But as it's only the fault in the memory, core data keeps like references to objects that are in the database. It's not loading everything to memory because of the overhead it might produce. We are accessing such frame of the objects fault, and for each such access, it has to query the database for the actual value. And we see that it does a lot of stuff here. It's plenty of time. Like, where does it happen? Here, in this code. So actually, let's try to move to this code and see what's exactly going on here. So it's this. So first we are querying countries. So we have countries in the database, and each country has users. So it's simple. We have users from countries. We query countries. We want to process users. Okay, and this is the problem. We query country. For each country, we access users. So first, we are firing first level fault, which gives us a list of objects. And secondly, for each user inside this loop here, we actually access its last name. So that's why we were poking the database like all the time. What can be done about it is simplify it by optimize it by first prefetching the users relationship and making sure that the objects returned here are not false. Oh, obviously you have to mind if you have like 100 megabytes of records, it may not be a good idea to do it like in one big query. Rather you may want to use batches. But let's see how the execution changes over time. I won't save it. So we are back to core data. We are back to recording stuff. And we are go back to cache misses. It's the very same execution. The fetch is significantly slower, but I believe it's significantly faster than all the cache misses so far that were being marked down. So it's also, this core data instruments is also a great tool for like profiling and checking the bottlenecks of your database access. It's useful, but unfortunately it works only on the simulator, which is a really big issue, I believe, unfortunately, because, well, it's better to be closer to the hardware, especially that iOS SQL library works differently than this one what we have here in terms of performance. And the performance difference is quite a serious one. Next, energy diagnostics. And I don't expect anyone here to raise a hand that they actually used it. Yeah, and I am right. It displays general energy info usage, tracks on and off states, and data can be gated and provides something useful, that the data can be gated offline. And that's mainly something I would like to point out to you. If you have your iDevice here and you enter the settings, actually, there is like a developer tab in the settings, yes? Each of you have this. If you enter this inside, you have instrument section and logging. And inside there's energy tab. If you can start recording while moving around the application, like having it like run, and when you decide it's done, you can stop recording. And when you are, you can like go around with this tool for about an hour or so and check it. I see some people are checking it or messaging someone because I'm boring them. That's fine. I don't mind. If we try to look at this energy diagnostics usage, in the instruments, we can import logged data from the device. Unable to import. It's no longer connected. Okay. Cool. Thank you. I believe I need to do it like that. Okay, yes, I need to do it like that. Coming back to this, coming back to this. Yep, we have some data gathered here. So it's only a short period of time, but if you like turn it on, move around with your application, like to home, if you have like location aware notifications, if you have a Bluetooth communication, if you use Wi-Fi, GPS localization, everything will be tracked here, and it may actually help you understand why the battery is draining so fast for you. That's something I actually find interesting about energy diagnostics, but it's awesome, but it must be, right? I believe it's difficult to, but sort of, but like I wrote here, it's difficult to extract from it true information about what is actually going on there. It's like, it's not like a good way to really tracking down the problem with energy. Rather than using it, you may think about how many things you are processing inside your application and how much of the CPU is like and how much battery is wasted on the CPU. Next, instruments over Wi-Fi. So, wait, you mean I don't need to keep my device plugged into my computer? You may wonder. And my answer is sort of. Well, instruments over a Wi-Fi, it's there. So it has to work, because if you think about it carefully, you may want to track the problems of like with accelerometer, with another stuff like localization, and especially I think it's about USB dongle that you may attach here, and also may want to debug it. It would be impossible to like run instruments and at the same time keep the dongle or whatever external accessory attached to it while you are using instruments over the cable. Yes, so I'm not sure if it will work actually here over the Wi-Fi. I hope it will. If not, then just trust me, it's possible. If you choose the instrument, whatever the instrument you really want to, here let's make it like energy diagnostics. Okay, cool. We can see that my phone has option for the wireless. If you press the option key, you can disable or in the first place enable this. Like it's like a hidden option that obviously is here for everyone to know. Yes. So we can select wireless options and choose the target, like instruments demo we are interested. No, first we need to do it like that. Run it, obviously. Okay, we are running. And we try to switch to the wireless. We choose target. Let's say it's this. And try to record it again. And I'm going to unplug this and see if it will work. If it works, then it works. If it not, then it's too bad. Oh. It works. So, okay, someone is actually listening to me. Cool. Okay. So, that's all. Thank you very much. And any questions or thoughts, then I'm here to answer them. Nothing. Yo, one.
You showed us a lot of really cool stuff you can do with instruments, but since you were turning on and off all those options, small radio checkboxes and so on, where can someone follow to get more data, more tutorials on how to use that?
Okay, that's a good question. Where did I learn from? Basically, point and click learning with trying every option there available. Also, really, if you have chance to attend the iOS meetup with the that is Apple organizing, WWDC, be it iOS 7 Tech Talks that there were around the world, go there. Really, there were I was in the Berlin on the iOS 7 Tech Talks, and there was a room full of Apple engineers ready to talk to you. Simple like that. It's like a tremendous amount of knowledge gathered in one place. Like the place was buzzing with brain power. Yes, so you could learn a lot of things from there. And Apple has some documentation for the instruments, Actually, they have like old documentation, but also a new documentation that highlights the options and just gives you a quick rundown of things to look at. Other than that, like playing, trying, learning, and a bit of Stack Overflow, but I find it that iOS community does not really use instruments a lot, which is a pity, in my opinion, because the tool is really great. I'm definitely planning to putting on some tutorials on how I'm using the instruments, because I don't think there's a really good tutorials out there. Looking at, for example, the iOS Dev Weekly that comes out, there was an issue, I think 1 week ago or 2 weeks ago, that highlighted some of the instrument stuff, but it was also like a really top level overview. We rather lack the detailed stuff, I believe.